Okay, we are in Chapter 6, Developing the Project Plan. In the first lecture, we learned about the network diagrams and how we link the tasks in there. Now we're going to take those diagrams and do a forward pass on them and a backward pass, and you're going to see how that benefits us. So, forward pass. We're going to get from that how soon an activity can start. Activity is a task. How soon an activity or task can finish. But the main thing we're going to get is how soon can the project finish. We had tasks and all these tasks, and we know how long each one is, but until we link them, we don't know how long the project's going to take to finish. Now, even then, we don't know what's our critical path until we do this backward pass. That will then tell us what path is critical. Now, in some of these simple diagrams we're going to do, you can look at it in your head and figure it out. But the key is what happens on a longer project. And this is, again, where Microsoft Project is going to come in and help. But this will give us an understanding of Microsoft Project and what's going on in the background. So now we're going to take these and make them a little bit more detailed. We're going to have this little grid. In the middle is the ID number of the task, and then down here is the duration of the task. So we kind of had our ID and our duration. Now we're going to figure out the early start, early finish, late start, late finish, and the duration. So forward pass, it's easy. Going to take the early start and add the duration. We'll get our early finish. We're going to take that early finish and move it to the next task in line. That's going to be now the early start for the next task. Unless there's more than one thing feeding the next task, we have to take the latest of the early finishes and merge that over. We'll see that in a second. So here was the project we laid out before. Now I'm going to lay it out with the grids, okay? But I'm going to jump back to my overhead camera, okay? Here is that little grid we have to do. Here was the project up here, all right? So let me just get the grid redrawn, but with our grids laid out. So task A, I go over here, 5 days. I have B dependent on A. B is 15 days. This didn't really say days up here, but I'm calling everything days. C over here is 10 days. And D here is 5 days. And remember, we had all those linked. Okay. Now it says E depends on B and C. So we had E over here. E was 15 days. Depends on B and C. We had F depends on B, C, and D. And F was 10 days. And it depends on B, C, and D. We had G depending on F. And G is 170 days. And we had H depending on both of these. So H, 35 days. Okay, now we have all that. We actually don't need this anymore. So let's just look at that. And now we do our forward pass and our backward pass. Let's start with our forward. So we have over here A and It starts at 0. I add 5 days. It can finish at 5. Well, B, C, and D can't start until A is done, because that's what the team said, so they can only start at 5. I add 15, that's 20. I add 10, that's 15. I add 5, that's 10. Okay, now we have E. E depends on B and C. Well, if it depends on B and C, I can't start until B is done. So I have to take the largest of these values and put it in here. 35, so that's done at day 35. F can't start until all 3 of these are done. Well, if I wait for the longest one, again it's 20. So now I have that plus 30. So now F is done at day 30. So I can move 30 over to G. So 130, some 30 and 170 is 200. H depends on E and G. Well, I can't start it till G is done. I can't start this till 200. So 235 when I add that on. So now I know this is a 235-day project. Again, with this simple one, you could have figured that out probably in your head, but this shows you how you go through and figure out the length of your project. Okay, that's the forward pass. All right, and then in your presentation, you'll see that here. Okay, if you want to take that and print it out and try it on your own, you'll get the 235. Okay, now that's the forward path. We haven't done the backward paths yet. Let's go do that. Backward pass, late finish minus the duration gives us a late start. Let me blow this up, I guess. Late finish minus the duration, late start. Carry the late start to the next activity where it becomes the late finish. Now when we say carry it to the next activity, we're going backwards, and unless it's a burst, and then we have to carry the smallest of them. So we'll see how that works. So now let's go do the backward pass on this here. Go back to this. So backwards, well, 235 is the late finish minus 35. That's still 200. Okay, well now I can bring this 200 back. So okay, this could finish at 200 and this could finish at 200. Subtract 170, I got 30. Subtract 15, what's that, 185. Okay. Now remember up here we said slack. Early start minus late start. Well, we got no slack in this. 30 minus 30, I still have no slack there. 185, I have 165 days of slack here. Now I go backwards. 30 comes here. 30 minus 10 is 20. 0 slack. Now I have to go backwards. So I look here. I have, let's look at D. D only comes from here, so D I can put 20. C comes from here and here, but I have to take the smaller value, 20. B comes from F and E, but I have to take the smaller value, so 20. 20 minus 15 is 5. 20 minus 10 is 10. 20 minus 5 is 15. So now I have 10 days of slack here. I have 5 days of slack here. And I have 0 slack here. Now I go backwards. I have to take the smaller value, 5. 5 minus 5 is 0. 0 slack. So now I look at my critical path. Those are tasks that cannot slip. So they have 0 slack. So critical path starts at A, but then it goes to B. Then I says, well, that has slack, this doesn't. So now my critical path goes to F. Now my critical path goes here and goes there. Again, for this small project, you could have probably figured that out. But again, what this is saying is A can't slip, B can't slip, F can't slip, or H can't slip, or G, or H, or my project's in trouble. I can slip this task anywhere in here, as long as this task E is done by day 200. I could slip C up to 5 days and still be done in time for F. I could slip D up to 10 days and still be in time for F. So these are not critical at this point. Now you may have reasons you need to get them done in certain times, but according to our schedule that we've laid out with the team, we now know this is a 235-day project, and my critical path is A, B, F, G, H is critical. So I now know both of those things, 235-day project. So let's go back and look at what that means to us. Okay, so there that is. We moved it here, moved it back, and came up with that. So free slack or float, you'll hear it termed differently. Free slack or float is the amount of time an activity can be delayed after start of a longer parallel activities. It allows flexibility in our scheduling. Okay, we can move those tasks around however we want. Sensitivity is the likelihood that the original path will change. So normally when you're doing this, and the tools can give you some of this, is okay, I know my critical path. Is there another path then that it's the next critical path? Because you might want to look at the top 2 or 3 critical paths so you know what's coming up. Okay, and that's the second path that would have the least slack. So here's our diagram. This is it filled out. I did that for you by hand. So we said our critical path was A, B, F, G, H. Well, our next critical path here would be A, C, because it has the least slack, okay, through there. And so I still maybe want to watch C because it's only 5 days. This has 10 days and 165. They're probably not as critical. So I might want to be paying attention to C also because it doesn't have as much slack. So you can get the second critical path and the third critical, and you now need to know which paths you need to watch. Here's a free slack example. So I can tell you the difference here. What's free slack and total slack? Okay, and sometimes those get confusing. So let's look at this. Here's this in this diagram, the critical path goes through here. Okay, but these 2 paths have slack. But there's the term free slack and total slack. So total slack is this number in the box, okay? That's really your total slack. But is it really free? And what they mean by this is, let's take test software. It's free in the sense that if it moves anywhere in here, because I have 16 days, I don't care because these people over here waiting for this won't be ready till day 30. And so I don't need to let them know. I kind of have free time in here. This task, yeah, it looks like it's got total slack of 16, but if I'm late on this task, these guys over here, I'm sorry, I say guys and gals, these people over here are going to be waiting for this to be done because they think it's going to be done at day 6. So they're gearing up to be ready for it. So it's not free. If you're late, you need to let them know because they could be working on something else. Here, you don't need to let this team know because they're not gearing up to getting ready until 30 because they weren't expecting it till over here. So this is total slack versus free. This is free in the sense free, nobody cares. Here people do care because the next team is waiting for it. So just be aware of that terminology out there. And in this case, if you are the software coders and you're going to be late, you need to let TUS software know so they can be doing something else. Practical considerations on logic errors, activities, and things. Let's look at some of that. So you don't never draw a loop like this. That's illegal in these network diagrams. Let's look at this one. What do you think is missing here? So if you were to look at this, and if I look at your network diagrams when you start turning them in later as part of the project, and I look at those, look at what's happened. I don't have a connection from this box. Where is this box going? In general, I will say, I expect every box to be linked somewhere. What's the purpose of doing the task if it's not linked somewhere? Now, there's rare exceptions for that, but in general, it needs to go somewhere. That's the whole idea. So this should have really had a link up here also to assembly. You can't assemble, you can order the parts, but you got to produce other parts. The whole idea is you're taking the ordered parts and the parts you produce and you're assembling them. Just having them stick out here, what am I doing with them? So look at your diagrams and make sure everything is linked. This is a mistake that a lot of people make up front in not linking all of their diagrams. And if you were going to do this in project, we would see it linked like this and how all these are linked together. Okay, so that takes this part here. Went through those diagrams. Now we'll go through and look at some other features in these network projects, because everything we've done now is taken one thing, started it, and linked it to the next thing. These can get much more complicated than that, so let's look at that next.